Alright guys, here's the quiz review. I'm using my new headset, so hopefully you don't hear all the clicking and the noises. Hopefully this works well. I'm going to start off with the two hard ones that people requested, numbers 29 and 33. With 29, you have to get everything to the lowest base number as possible. So 5 is already the lowest it can be. 3 is already the lowest it could be down there. 36, if you break down 36 is 9 and 4, which is the same thing as 3 squared times 2 squared. So I can turn this into 3 squared to the 1/3 times 2 squared to the 1/3 times 5 to the 5/2, and then all over 3 to the 5/2. I'm sorry, that's to the third, or 5/3. Alright, next thing I do is just simplify these up here, figure out what these numbers are. So I have 3 to the 2/3 times 2 to the 2/3 times 5 to the 5/2 all over 3 to the 5/3. The reason why I did it this way is because if you look now, these are let's see, these here you can simplify by subtracting the exponents, or you could, like I said, cancel them. You have 3 to the 2/3 minus, so 2/3 minus 5/3 is 3/3 on the bottom. So this turns into, on the top, 2 to the 2/3 times 5 to the 5/2 all over just 3 to the 3/3, which is just 1. So we don't have to do anything with this now. This is good. We just have to fix the top now. We need a common denominator. So we need 6. So if this is 2/3, this is the same thing as 4/6. And if I need 5/2, this is the same thing as 15/6. Okay, and then the last step is, how many 5s can we take out? Well, we can take out 12. We can use 12 of the 5s because 12 over 6 is 2. So I have a 5 squared on the outside, and then these are 6th roots on top. And then I have 2 to the 4th, and then if I use 12, that's 3. So 5 to the 3rd all over 3. So my final answer is this, and if you simplify it more, you get 25 the 6th root of, I forget what this is, 125 times 8, 250 times 4 is 1,000. No, I'm sorry, this is times 16, so it'd be 2,000 all over 3. Okay, so that's number 29. I'm going to do number 33 now. 33 is very similar, actually. We can rewrite this and break this down. 81 is the same thing as 3 to the 4th. So this turns into 3 to the 4/3 all over 7 to the 1/4. Now the problem is we can't have that on the bottom. We can't have a radical on the bottom. So I need to multiply the top and the bottom by 7 to the 3/4, because that is what will give us 4/4, and then a full 7 on the bottom. So 7 to the 3/4 here. And now we can rationalize the denominator, so that's a 7. And now we just have 3 to the 4/3 times 7 to the 3/4. Now if you want to take the 3 out now, you can. I like to wait till the end now, I guess. It's simpler. I'm going to turn these into 12ths, so they have the common index. So if this is a 12, I need to multiply by 4, so this turns into a 16 over 12. And this turns into I need to multiply by 3, a 9 over 12. Okay, so I'm going to rewrite this so I have an index of 12, but I can take one full 3 out because of the 16 over 12. I can use 12 of them and take a 3 out. Now when I do that, I leave the 12th root of, I have 4 of them left. The 7s didn't have enough to take out, 7 to the 9/12, and then all over 7. And that would be the final answer. I believe you can leave it like that. These kind of get big. You get big numbers. So, all right. Those were the two main ones that people ask questions on. I'm going to go down and do a solving one. Actually, I might do both of these. Solving is normal, just try to get x by itself. So the first step is subtract the 1. You get 7x minus 3, the fourth root of that, equals 112. And then you get, I believe that's, yeah, divide by 7, and you get 16, I believe. Yeah, that is correct. So now here's the key here. You get down to this only. We have to take the fourth root or raise it to the 1/4 power to solve this. But if I'm doing that with an even index, then I have two possible solutions. So I can get x minus 3, actually I don't need parentheses anymore, x minus 3 is equal to plus or minus 2. You get two possible solutions. So if I add 3 to positive 2, I get x equals 5. Or if I add 3 to negative 2, I get x equals 1. Those are my two solutions for this problem. If I move over to 36, the first thing I have to do is multiply by negative 9. So I get x plus 4 to the 5th is equal to, I don't have my calculator with me. 9 times 7 is 63. Oh, I believe it's 243. Yeah, we'll go with that. So negative 243. Then you have to take the fifth root of 243. And now notice how I have a negative, but I am doing an odd index, which is acceptable for negatives. You can multiply something 5 times and get a negative number. So my final answer then, I have x plus 4 equals, I believe this is negative 3. And remember, there's only one solution, not two, when you are taking a root with an odd index. So my final solution for this is x equals negative 7 only. Okay, so be careful about that. Alright, well, I have about 8 minutes left, so let me find a couple more to do. Let's keep working on this side. Just for everyone's information, this is a negative 1/3, not a 1/3. Let's do this one. So this turns into, first of all, negative can stay outside because it has it's to the third root, so it'll just come out because it has an odd index. So I'm going to turn this into negative 1/48 to the 1/3. Now, some of you guys might try to break this down first, and I actually did that on the key, but you can also rationalize it now. So I'm going to rationalize by multiplying by 48 to the 2/3. Okay, so you get 48 to the 2/3 on top, all over 48. But we have to fix this. We can't have 48 to the 2/3 on top. We can break down 48, and there is still a negative out in front. So my next problem is breaking this down. If I break down 48, I get 16 and 3, and 16 is 4 and 4, which is 2, 2, 2, 2. So it's 2 to the 4th. So I'm going here, and I'm going to go back down here now. So I get 2, I still have the negative, to the 4th times 3, all to the 2/3, all over 48. Okay, now I multiply that fraction in. I have negative 2 to the 8/3 times 3 to the 2/3, all over 48. They're both in thirds, so that's very beneficial. This one, I need groups of 3 to take a 2 out, so I can take 2 2's out. So I get negative 4, because 2 times 2 is 4, that's where the 4 comes from. And then I'm left with 2/3 left, so I can say under the radical, or under the third root, I have 2 squared times 3 squared, all over 48. My final answer, I can divide 4 into 48. My final answer is negative. On top, I have negative third root of 2 squared is 4, 3 squared is 9, 9 times 4 is 36, all over 12. Because 4 divided by 48 is 12. 9 times 4. Yep. So that is the final answer for number 28. Okay. Let's go back up here and do one of these up here. That's real quick. Look for like terms. We can't do anything with those, but we have a 3 and a 1, so this is just 4x to the root 2. Don't do too much with those. Same thing with this. These are like terms. It's 1xy to the root 11 minus 3xy root 11. 1 minus 3 is a negative 2xy root 11. What else do I have? I have, let's see. We can do let's do number 20. I have a square root here, so that means I'm going to be dividing everything by 2. I'm going to rewrite the inside as x to the, oh, I got another request for number 25. I'll do that one next. Alright, x to the 6m, y to the 8n times y cubed. I'm just breaking apart that. And this is the square root. Now don't forget the x, y out in front. I'm going to deal with those later. So I divide by 2, divide everything by 2, okay, and see what you can bring out. This divides evenly. 6m over 2 is 3m. So I have an x to the 3m out here now. That's this piece. 8n over 2 becomes y to the 4n. So y to the 4n. Okay. I also have 3 over 2. That doesn't divide evenly, but I can pull a y out. So this becomes times y. And then I also still have times x times y out here in front. And I still have the square root of, there was one remaining y in there. So combine everything. This is y to the first, y to the first. So there's 2 y's when you add them together, and the 3m and the 1x. So combine them back together. We get x to the 3m plus 1. That's the plus 1 from here. Y to the 4n plus 2. And then the square root of y. Alright, number 25. Alright, so number 25. I have, all you got to do here is realize we have the same bases. So we can subtract the exponents. So 2 root 5 minus root 5 is just root 5. So my final answer is x to the root 5. Okay? That is all you need to do for that one, because when we're dealing with roots in the exponent, we don't know what else to do with those. Again, when you're dividing by k for like number 14, I'll probably finish up with this one. You divide everything by k. This can divide by k, this cannot. This can divide by k, this cannot. This can divide by k, this cannot. So, I can take out a 7 to the third. That's this piece here. I'll do these in green. 7 to the third, because the 3k divided by k is 3. A to the 8k turns into a to the 8. And I use that piece. C to the 5k, so c to the 5th. And then we have the k root of things that could not be divided by k. That's 7 to the 1, a to the 10th, and c to the 2nd. And same thing with this one over here. Nth root, I can divide by n's. They all cancel out. So I get 6 squared, m to the 8th, p to the 5th. We can rewrite that, so 36 m 8 p to the 5th. Okay. Alright, so this should be a lot of problems for you to look at. Hopefully the number ones you can figure out. I only have a minute left, and I want to make sure it gets up, so I will stop here. Well, right now, real quick, 27, I would subtract these first. 2/5 minus 4/5 is 2/5 on the bottom, so you get s to the 3/2 over r to the 2/5, and then you need to rationalize, and then go from there. Okay, but that is how you would start number 27. And that is it for now. Hopefully you get something out of this and do well in the quiz tomorrow.